final thing we'll talk about is homeostasis. So the term homeostasis is the body's ability to maintain a stable environment, internal environment, um, in response to changing conditions. So there are always changing conditions. You're laying down in bed and then you sit up. You have changed the amount of pressure that your blood has to get to all the regions of the body. You eat food, and so you've changed the amount of nutrients in your blood. And then your body has to respond to get rid of nutrients that it doesn't need, store them in different areas. You go without eating, your body has to respond by giving nutrients to the blood that it doesn't have, that it didn't, I shouldn't say doesn't have, didn't receive from food. So these are all continuously changing variables, and we have to be able to maintain a stable environment, okay? So to do this, the homeostatic, or the body has a homeostatic mechanism that has three basic components. We have a receptor, a control center, and an effector. A receptor is something that detects changes. So it picks up stimuli. And then it's going to carry the stimuli to the body, or to a region of the body, typically called the control center. The control center is then going to take in the information, and it's going to send a response out to another region of the body. So the control center basically processes. It's a processing center. It processes the information and determines what has to be done. The control center can be either the nervous system, and we typically use the nervous system for our fast responses. So withdrawing from something sharp or from something hot, that would be a nervous system impulse. The initial startle when someone scares you, that's an example of the nervous system responding. The endocrine system is a slower response, but it's going to last a lot longer. So if we don't have enough calcium in our blood, or if we have too much sugar in our blood, then the endocrine system is going to respond, and that response is going to last a lot longer. So it helps to maintain for a long period of time. And the control center is going to send a signal to another region of the body known as the effector. The effector is going to be a muscle or a gland that is going to respond, making sure that we stay in homeostasis. So there are two basic feedback loops that we use. A feedback loop, in a nutshell, is just, it starts with the stimulus that is picked up by a receptor. The receptor then takes the information and sends it to the control center. The control center takes in the information and decides what has to happen, and sends out a response through effectors, or through efferent, two effectors, that's what I'll say. And then the effectors bring about whatever change has to occur. So let's look at an example. This is from your textbook. This is figure 111. So think about your, you can look at your heater in your house, and you can also look at your body. So when you get too cold, that is going to be picked up by a receptor. In the house, it's picked up by a receptor, the thermostat. In the body, it's picked up by the skin. The body itself gets cold. And then it's going to send a signal to the control center. So there's the stimulus, it's picked up by a receptor. The receptor is going to send a signal to the control center. The control center in the house would be your heater. But in the body, the control center would be the brain, or, well, I shouldn't say brain, I should say nervous system or endocrine system. And in this case, temperature is controlled by the nervous system, specifically the hypothalamus. And so it's going to take in the information and say, oh, the body is cold. So what are we going to do? It's going to then send a signal to the effector. The effector in the house is going to be the blowing of the heat. So the heater turns on and starts blowing more heat out to warm the house up. In your body, it's going to be muscles or glands that are going to bring about a change. And in this case, the muscles are going to start contracting because a byproduct of muscle activity, muscle movement, is heat. And that's going to allow us to go back to homeostasis and be comfortable. So we have two basic homeostasis mechanisms. We have negative feedback, and then we have positive feedback. Negative feedback is the most common type of control in the body to maintain homeostasis. And basically what's going on is when you have some variable that starts to move away from homeostasis, negative feedback pushes that variable back to its set point. So if you start to get too cold, the negative feedback will push you back to comfortable. If your blood glucose level starts to drop, negative feedback will increase blood glucose back to normal. That's negative feedback. So the change is opposite whatever the stimulus does. Examples of negative feedback are the withdrawal reflex, which I have talked about when I talked about the touching something hot, or if you're stepping on a nail, you're going to withdraw your foot. Heart rate, blood pressure, carbon dioxide levels, glucose levels, calcium levels in the blood. Almost everything is controlled by negative feedback. The other feedback mechanism is called positive feedback, and in this one, we are pushing the variable, the whatever that stimulus causes, we push towards the stimulus. So we move the stimulus farther and farther away from that set point until we snap back into homeostasis. Typically, we're going to hit some climactic event, and then we're back to homeostasis. So example of positive feedback, the best example is childbirth and breastfeeding. But blood clotting is another example of positive feedback. So in positive feedback, and I think, don't I have a picture of this? Yeah. So here's information. I'm going to go to the next slide and I'm going to explain it, okay? So in positive feedback of breastfeeding, a baby suckles at the breast and there are receptors around the nipple. So when the baby starts to suckle, the receptors pick up the stimulus, the sucking. That sends signals to the hypothalamus. The hypothalamus then tells the posterior pituitary gland to release oxytocin, which is a hormone. Oxytocin functions in the letdown reflex of milk. So it allows milk to be ejected from the mammary glands, and the baby gets milk. And when the baby gets milk, the baby sucks harder. And this is going to stimulate more oxytocin to be released. And this occurs until the baby is content. Another example is labor. So with labor and delivery, oh my goodness, one of the bad things about this is, yeah, I don't know how to fix that, but with labor and delivery, we start with the baby releasing chemicals that stimulate the body to start releasing chemicals. When the baby hits the cervix with his head, the cervix has receptors that send signals, again, to the hypothalamus. The hypothalamus responds by releasing or by telling the posterior pituitary to release oxytocin. Oxytocin stimulates uterine contractions. It also stimulates prostaglandin release, and prostaglandin release is going to stimulate contractions to become more intense. And then you're going to have a large contraction that squeezes the baby, pushing the baby towards the cervix, and the baby's head will hit the cervix again, causing more stimuli to be sent to the hypothalamus, causing more oxytocin to be released, causing more prostaglandins to be released, which will continue until that baby gets out of the body, leaves the uterus through the cervix and the vagina, and is expelled. And that's that climactic event. So homeostasis is dynamic. It's not a static system. So our organs or our homeostatic mechanisms constantly change with the body. And we have to be able to maintain homeostasis. If we leave homeostasis, that's when disorders and diseases occur. And so we use the healthy body to determine when a body is not healthy. And once we realize there's a body that's out of homeostatic balance, we can then use a diagnosis to treat whatever imbalance or disorder they have. We can use medications, we can use X-radiation to look at the body, we can then use casts or medicines to bring us back into homeostasis. And so we'll be talking about homeostasis throughout the entire semester, so make sure you understand it. I do have a couple mini videos posted under Chapter 1, Help. I think it's called Chapter 1, Activities to Help. Look at them, mess around with them, and see it to make sure that you understand this concept. So homeostasis never leaves. It's around for the duration of your career in anatomy and physiology and in the medical field if you're going into that, okay? I'm done with Chapter 1, so I will see you in class and we can discuss the information that you've learned. Bye.